So I'm going to talk about few algorithms. So we talked about CCR. I didn't go algorithms now, and there are so many of them. So I, of course, can't go in all of them, but there's some common ones, big ones. So first one, the simplest one, I mean, simplest from the understanding perspective, is called as linear regression. Out of the category CCR, which category do you think this one will be? Regression. The name says regression. But be careful, because I have given you a knowledge which could sometimes you can be dangerous. There is another one which is called as logistic regression. It has the word regression in it, but it's not a regression technique. It's a classifier. So just be aware, not everything is this way. So only that one is a problem. It has the name logistic regression, but it's creating a line and then it's saying whether this one belongs in this category or not. So it's doing classification by creating a line. So that's one you just remember. Now linear regression. What is the linear regression? That's the only math which I'll do, try to put together this way. The equation of the line, right, is what? Y is equal to mx plus c or mx plus b, depending on where you did your education, right? Asia or year, depending on that, it will change. That is the constant changes little bit. So that's what is happening. There is a weight value and there is a constant value which is part of it. So that's what the line of equation is. So that's what linear regression is trying to do. So most of the people know that. It's very simple. And what's really happening, let's think about this example. Now I have a data set. So these red dots are some data points, right? And these are two x and y axis. And there's some data point. So let's say this point is at 0 at and the x and 1 or 2 or something at the y, right? So we have plotted this point. We have plotted this point of time, right? This may be the height, weight, the height thing which we were talking about, right? The age. It's not, but assume like if it was the age over here and this was the weight of the person, right? That's the same regression model we talked about everything. And the doctor is trying to create a line which will say this person's age is what it's going to be. It's very interesting that when I draw the line, in fact, you notice that majority of the points are not even on that line. Like many times it is going up and down or less wrong or something, which we call as outlier. The more away it is, the more it is outlier. It's not falling in the median or the normal pattern. It's different, right? So when a doctor says something about this person who is like right off the chart, and they say your weight is going to say in so way, and they'll say your model is rubbish. That's all nonsense for this person because it's all the way up on the outlier kind of thing. This person, all of these people will say that. But when you have substantial amount of data, then the model starts becoming more and more accurate, kind of over a period of data. Now, how the system or the model is going to do internally. So you got these all data points. Forget this is the blue line. This is the line which is coming output. This is the final output which the model has told you. This is the line, right? How does it come to it? So what it does, whichever model, it is SciPy or Python based or whichever, the algorithm internally is doing this thing. It's going ahead and calculating the distance. I mean, it's first of all creating a line, just randomly any line, best possible line, these things. And then it's doing calculating this distance from each side. How much distance this point, all the points. It is just going to internally calculate for every single point. Come up with a number. It will actually square it. Can anybody guess like why they square it? They can square the distances. It's a very common sense question, but it may be not coming pretty quick, but it's positive and negative values to eliminate that. So if we say somebody is very heavy weight and somebody is underweight, doesn't mean they don't exist. There are two people. They should not negate each other, right? If you just add plus this much and minus this much, it should not negate each other. That's why we are trying to balance. Thank you for that. So that's why we are squaring it. What it will do, what I said is like it will draw one line and calculate from that line each of these points, how much far they are, like each one, and calculate the square of each of them and come up with a big number. And whatever they call is the residual error. How much error this line is having, right? And it will come with a number. Then it will try to internally plot another line and come up with the error for that, some error for that. Whichever line has the least amount of error value, that's the line which the model says, this is the best possible thing. I can't do better than this. There is going to be error, but this is the best which I can do. Based on the data which you have given, what we can do is, and this is the pattern which we will define. With this, we'll define some terminology also. because in the data science world, I think there's a lot of terminology behind as well. So let's understand and clarify your terminology. Let's say I have some data, which is lines of code written by an individual, and I have 3 of these columns, if you call it, gender, pair programming like 2 people sitting and programming, and how many social media accounts they have, right? And this is line of code. Now, first of all, let's understand some terminology. These columns in the data science world, we don't call them as columns. We call them as features, right? So this is the terminology which we call, never call them as columns. These are called as features. And we are selecting the features. So we're generating the features. So this is which features are more useful or not, so features. And this is my output or target, that Y value, which is the end result. So that is called as the Y, and that's called as a target or output, one of those. Mostly the target it is called as. We have features, we have targets. And then we have all these rows, right? All these different rows. We don't call that rows in the data science world. We call them as samples. Right? So this is some terminology which I'm trying to say. They are similar things which you have seen before, new kind of way of approaching it. But in the data science world, that's the terminology. So going back quickly, there is features, which are a bunch of columns, and you select and which one is more useful or not, or better or not. And then there is this output, which is the end result, target, and then there is samples. Everybody okay with that? Basic terminology. That's what we are doing. So what we are trying to do is trying to, first of all, machine learning to be ready for the machine learning programming. This kind of data machines don't like. Machines like numbers, 0, 1, some numerical values. They don't like this. So this has to be first converted. So you have to do that job. Give the data, let's say gender, you'll have to convert that into zeros and ones. Some kind of logic behind it, right? So male, 1, female, some kind of logic. So it will be converted on that. Once we have converted into that logic and feed to that, the model will take this and say, these are my X values, and give weightage to each of these things. How much important the gender is going to be? How much important is this pair programming hours are going to be? How much is each of these things? And come up with a Y value. It will try to not only single variable, it will have a multiple variable kind of a thing. It could have. It doesn't have to have a single variable. Many times it will have multiple things. Another example, let's say you are predicting or looking for defining apps. You're creating apps and you're putting on the store, and there are different kind of combinations. So if you did not do anything, you created an app, put on the store, just created an app and so put on the store based on this formula, how many apps will be sold if you didn't do any marketing? 46. So that's your constant value. Even if I don't do anything, this is what how many apps are going to be sold. But if I do $100 marketing, which is X1, this many $100 marketing, multiply that many marketing, I will get 35 more apps sold. If I do to public talk, I'll get 27 more apps sold. If I did targeted podcast, that will give me 52 more apps. So the machine is actually finding out which one of them is more important, and you tell me which one is more important of the 3. The last one, the more bigger the weightage it is. So this one, the machine has figured out like putting money into this is more better, or effort into this is more better. So this could be used in various ways. That's the fascination people have. Like, wow, suddenly this data is starting to tell me a lot of different things. So that's the amazing world we live. So that's what linear regression is trying to do, is come up with some kind of equation like this, or with a single variable or multiple features. Right?
So in order to come with those numbers, someone has to write the algorithm and look at the historical data, and how do you come with 52?
Correct. Numbers? So not write the algorithm. We are going to feed the data. Yeah. We are going to feed all this data, and looking at the historical data, it says, oh, this person, whoever did more podcasts, got more results based on that, everything. So it's all historical data. Yeah. It's all about historic data. Again, as I said, data is oil. Data is everything. Key. Yeah. Otherwise, you can't. Otherwise, it's a crystal ball.